Right, so the fourth solid principle is interface segregation. So let me just create the file for that. So interface segregation principle.ts. So we'll give you a functional example, but I'll explain what it is first of all. So you can see here, the definition is clients should not be forced to depend on interfaces they do not use. So we want to create specific interfaces for different functionalities. So an example is splitting a large interface with many methods into smaller, more specific interfaces that clients can implement as needed. So pros reduces unnecessary dependencies. So if you're using a type or an interface, then if we can split it down into smaller chunks, then that is essentially being able to identify what is needed within a certain function or component or type. It improves clarity. So smaller specific interfaces are easier to understand and implement. And then again, maintainable because it changes one part of the interface. It doesn't affect any other interfaces. So if we choose a type, then that is used across multiple functions but only takes in certain subsets of that type, then essentially what we need to do is use something like TypeScript or whatever you're using in an example, and you can extract the subtypes from there and create a more specific type for the specific function that you need, something that isn't adhering to this principle. So let's do the functional example first of all. So now you can see this example is violating ISP because here it says splitting large interfaces with many methods into smaller, more specific interfaces. So now you can see this has many methods in this interface of worker. And again, this human worker has work and eat in here. So what we want to do essentially is split it into smaller methods. So the worker interface here we could split out. So let me bring in the correct way to do it. So we should separate out the work method and the eat method. So let me just comment this out and bring in the code, the correct code in here. So now we can see here, this is an interface of workable and this is an interface of eatable. And then now you can see here that human worker is A, workable and B, eatable, whereas the robot worker is only workable because it doesn't eat, obviously. So using this now, using this principle, what we can do is we can do human worker dot work and that returns working. We could also do human worker dot eat and that returns eating. And then we could do the same with robot worker dot work. But if we do robot worker dot eat, then this returns an error because it tells you that this is not a function. So if we go up to the other example here, this will throw a new error in here. Robots do not eat, which again is not correct because robot workers don't eat, and again this method should not be available in there. So what we can do is we can essentially just take it out, and then it takes, if you hover over it here, property eat does not exist on type work on here. So essentially we know that when we invoke this is going to throw an error, so we don't need it. So let me just save that. And what essentially this principle is doing is it's making it into this because you could have multiple lines of methods in here. So it could be work, eat, play, sleep, and so on. But what we want to do is be more specific with the name of the interface. So this one is workable, this one is eatable, and then we can add some more in here, interface of work extends, and then so on. Or you could just keep it simple. So single responsibility once again. So this one is sleepable like that. And then again, you can do sleep and it returns type void. You can return a type of string mainly because this one is a string. It's always, at the minute, it's console logging, so it will be type void. But again, if you wanted to return something else like a string or a boolean or whatever, then you can do that as well. So this one's quite simple because it's easy to do, it's easy to implement, and then you can break it down further. So now we have a single responsibility or one interface that basically does the one thing in here. And if you wanted to extend it, so we wanted to do the same as above, so let's do this one. What we should do instead is after this interface over here, what we should do is just name this to something else. So human worker, because a human worker can work, eat, and also sleep. So let's do that. And then again, you could pass this interface into here like this. And now you can see there's an error because we've not declared sleep. So again, we could make this optional. So the human could sleep, could not sleep, but again, everyone human sleeps, so we need to add that in. like that. So now you can see if we add the types into robot worker as well. So again, robot worker we don't have. So the only thing it does is workable. So let's push that into the type over here. And that is fine as well. And then again, this throws the error. We are specifying the interface or type for this constant over here or object that has the methods inside it. And then we can then essentially handle it. So this interface is for one specific thing over here, which is the human worker. And then you can also extend it further. So if you wanted to do the workable, we know that workable applies to both. But again, this type here is more specific because this one has three methods on it. So it's about creating your individual interfaces or types and then segregating them out so they are responsible for one thing and one thing only. So that is the interface segregation example. One more example we need to do is for React. So let me go ahead and create a new file. So isp.tsx. And essentially, let me do another example. So this one is violating the ISP, should I say. So the user profile props. Again, this takes in the name string, email string, on save and on delete. So this is very common when you pass in props. You have this kind of shape in here where it takes in many different types of props. And then these props are passed into here. So you can see user profile props, it takes in all of this stuff over here. So that is a very common thing that I see quite a lot. And I have done it myself. So it's something that it needs to be worked on to make sure that we are following our interface segregation principle. So let me just save that. So that is violating it. And then now this is the example where we are adhering to ISP. So if I bring this in underneath, now you can see there's a lot of different things going on. So all you needed to do was these are different to these ones, as you can see here. So this is a string, and then these two are methods. So what we should do is essentially split them out. So now you can see we have user profile props, which is the name and email, and then we also have the user action props in here, which is on save and on delete. So what I've essentially done now is separate the user profile props out here. So this is solely responsible for the user profile, and then this is responsible for the user actions. And now you can see this is the interface declared for this one over here. So we are segregating the interfaces out into the relevant sections that they fit in. And then all we do is we would render the component for the user profile, which renders all of that user information out. And then any actions that we want to do, such as on save and on delete, this is handled over here. So you can see here we console log save and delete as well. So this is a classic example of interface segregation where again they all tie into each other. So this is also a single responsibility because it's handling the user profile information. And then this one is also a single responsibility. But again, this one over here, so the on save and on delete are extendable. So they are open for extension as well, because you can have handle update in here as well. So const handle update. So you can essentially extend it further like this. So handle. So now you can see this is open for extension as well. And then it's showing an error. So all we need to do is go into user actions over here, and then you would do handle update or on update like this. And then you would go into user action props. And then here you would do handle update, it returns type void. And then you can see now that all these principles are falling into each other's hands and they are helping each other out. And that way you would have a more robust and scalable code base as well. So you can see how they are intertwining and linking each other together. So now we just need to focus on the last one, which is dependency inversion, and we will do that one next.